it's unfortunately we have to do an example using the principle of induction.
Do we have to?
I think it'll be good. I know I don't want to do it, but okay, let's do this. So this is the proof. And we're just gonna apply the conditions. And the conditions have been successfully applied, the first two conditions, then the result will be true. Okay, so we want to prove that this formula works for any, so if I replace n with, let's say, 425, this formula will add 1, 2, 3, 4, plus 5, plus 6, plus 7, plus 8, plus 9, plus 421, plus 423, all the way to that. This formula, doesn't matter how big or small n is,
Yeah.
it works. It will add for every n that belongs to the set of natural numbers, the sum of the first n natural numbers is given by this very famous formula right here. And we need to prove by using the principle of induction that this formula works for any n. So our base case is 1. So we go with me. All right. So if n equals 1, is this true?
Yes.
So well,
Yes, it is.
yeah, and also we add this side as well. So how long is this side? So we're going to do this with this condition, right? So this is going to be just 1. The first n numbers, if the sum of the first n natural numbers, if n equals 1, we just have 1 on the left hand side. Right? And then on this side we have, and then you insist it's 1, don't be such a mad demon. We need to check. This becomes 1/2, this disappears, we got 2.
It does not work for 2 though. Unless I'm stupid.
No, it does. So
How?
it's going to be 3. 1 plus 2 is 3, and then 3 is going to equal to 2 plus 1 is 3. Because these two will get cancelled.
What?
Okay, let's do it for 2.
Yeah.
Even though it's not. So then this side is 1 plus 2, right? Left hand side. And then this is going to be 1/2 times 2. That's a 3, and that's a 3.
Oh.
And it does work for all numbers.
Why does it?
Yeah.
Why do you have to add the +2 to the 1 though? Because
Oh, okay. So you're talking about this side?
never mind.
Okay.
I see. No, I see.
Now you see it, right?
Yeah.
What is n equals 3? Tell me.
It's 1 plus 2 equals or +3.
And we stop there. First n natural numbers. So first 3. What is the sum of the first? Sum of the first 3 natural numbers. Good thing we stopped. So what's the sum of the first 3 natural numbers? The sum of the first 3 natural numbers is add the first 3 natural numbers. And if we stick 3 here, this is going to be 4, and 4 divided by 2 is 2, 2 times 3 is 6. So we already know this formula works because it's a historically famous.
It's just the it's the same thing on either side.
Yes.
Yeah.
Because this is the formula.
Yep.
And this is actually taking one number at a time.
Yeah, but
Adding
every number there is just a substitute for n, yeah,
Yes.
okay, cool, yeah, I get it. I was
Go with this
wrong.
first. This is what you need to focus on. Is this thing. First n natural number.
Which means it's gonna be the number, it's gonna be one.
Okay. If you say sum of the first one natural numbers,
Yeah,
there is no sum, it's just one.
yeah, okay.
It's kind of like a weird thing, but we have to use the hypothesis. We could have just gone straight to k, but that would have been wrong. Okay. Now we assume. Now we assume that k belongs to the set of natural numbers. Or actually, we have to do S, right? Because is there S here? Oh, the principle of induction uses the letter S. So we'll just do this here. That it belongs to S. Okay, so the number two, these are the two hypotheses. So if K belongs to S, then K plus one will also belong to S. So let's do this one first. So I'm going to move this here. If K belongs to S, then K plus one. All right, so this is, we take the left hand side, it's 1, 2, 3, the sum of the first K numbers, sum of the first K natural, small K's, this is small. I need to figure out how to write the other K's, the one with the.
It's like R,
Yeah, it's like a.
but you have, yeah, that,
This if and then we got the first, the antecedent down, right? Antecedent part down is, if antecedent, then consequent. So we just did that. So this is true. If this is true, then K plus one. So what we want is we want to formulate this formula for K plus one. We need to change this so that rather than just K, we have a K plus one on this side and a K plus one on this side. Okay, because what we're going for is this number. We're saying this also belongs.
so you just add one to each side.
Since I've cheated and I know how they do it, that would kind of work, but let's try that. That's actually good. Okay, let's try that. Let's see if it works. And that's where we should go. So if we do this, so now we have on the left hand side, we have this. So we're done for the left hand side, right? This is saying the sum of the first K plus one natural numbers.
This was a mess.
And therefore, the formula for adding the first the formula for summing of the first K plus one numbers is going to be here, right? And each K would be like this. This K would be K plus one, and then this K has to be K plus one plus one. Because this is our number.
Yeah, so it's gonna be 2, right?
So yeah, it will be 2. And so, in fact, the book, so when I used to do this back in the day, I would leave it like that. The book does this. It does 2. And the math major will be able to see it. But, so in other words, what we just said is If we add one to the right hand side, it should look like that formula that I just made.
Yes.
So does it? Let's see. I think not, but that's where we should start, right? And I do plus. And now it's up to you to try to see. So this is a product. 1 over 2 times k plus 1, and then we have a plus 1. We could do things like we could do 2
Yeah,
k, and then this would be plus 2.
that was exactly what I was thinking.
Yeah, and in fact, that's what you have to do.
Yeah.
Something similar in the actual example.
And then it's
Then it could potentially work, right?
k squared plus 1.
But it doesn't.
Yeah.
So this is a great idea. That's where I would start. You're like, okay, what about if I just add, because I'll instantly get that. So what the book does is, it does this. So this may work, probably doesn't, because the book doesn't use it. It says, just add k plus 1, this whole thing. And to the right hand side. Let's put it in. So this was the original, and then we added a k plus 1. This side is now fine, right? Now we need to make it look like that this is k plus 1 and this is k plus 2, right? And we're done. And so it turns out it's kind of,
That's not happening.
it does happen.
How?
It took me a while, but I'll show you here. This is a k plus 1, because we're replacing all the k's with k plus 1. The next number is also right, is also in there. So I do this. I'm doing the same trick here. So 2 divided by 2 is 1. So 1 times this number is k plus 1.
Plus k plus 1.
Plus, there's a 1 here. So 1 divided by 2. 2 divided by 1 is 2, so 2 times. Okay, so I want you to do this your way and see if you get this.
You want to do it the other way?
No, this way. Is this fine? Is there a 2 here? I'm just trying to make sure you're getting this thing.
I mean, we're getting into
Algebra.
I was about to say.
Actually, let me do this again. So this is how I grew up doing it, and my daughter doesn't do it like this. So I grew up thinking like this: k plus 1 is over 2, and then k plus 1 is over 1. Then I draw this line and I multiply 2 into 1, I get 2. Then I take this 2, divide it into 2, I get 1. And then 1 is multiplied. So I do 2 divided. I take this 2, stick it in here, 2 outside. This is 1. I take 1, multiply the top, the numerator, and I get k. 1 time this whole thing is the same. Then I come here, I take 1 here, stick this guy in here. 1 divides into 2. 1 times 2 is 2. We're done. I take this number and multiply it to the numerator. So I get this. So now is the trick. I'm forgetting the trick. 2k to.
You just divide by 2 because it's going to be 2k.
No, if I divide by 2, the end of it is. So I have to take. Okay, I'm going to take k plus 1 out of this whole thing. So I'm going to take this k plus 1 and I'm going to, okay, the guys in the ones with the hats, these 2 guys, right? I'm going to take these guys out and I'm going to say k plus 1, and I might make mistake. So this guy come out. What's left here?
Okay.
And what's left here? And what's below?
2. Where did the other k plus 1 go?
This guy?
No, that one.
Okay, let's do this again. Oh, that case, sorry, it's still here. No, it's not here. Sorry. Okay, so
Alright,
so your algebra really is
that's
bad.
bad.
Okay, here let's do this again here. This is a good moment. So you really have to do all that and then you'll be fine. Otherwise. Okay, so how do we do this? We're gonna use colors. So we got a K. And we got, so you wanna write this down since you're getting confused.
Yeah.
Plus 2. Okay, so you got this line. Now, this is a, what was this? A term. This is a term. This is a term. Okay, so these are called terms. This term has k plus 1, and this second term has k plus 1. These two terms are being added. Because they have something in common, we can pull it out. Okay, so I'm going to pull this out, and it will be still equal to what I'm going to do here. This expression that we're going to have will be identical to this one. So I'm going to take k plus 1 out, and now I'm going to use the square bracket. When I take, so I'm taking k plus 1 out of this sum here, from this term. What's left in this term here? So, what's the k, right? I take k plus 1 out.
Yeah, I'm sorry.
Okay,
Yeah,
so k,
plus 2.
and then I take this one out, and what's left is, if I multiply this through, I'm gonna get this back. If I take this in,
Oh,
see, I do the distributive.
I see.
From,
Okay. Yes.
okay, this is multiplying into this whole thing. And if you multiply it, you get k plus 1, plus 2, k plus 1. I did the opposite, I just brought it out.
I see.
Yeah, okay, and whoa. Oh yeah, we didn't go further on with that. Take that out. All right, so if we go back to the formula, right? Just to make sure, the formula should look like this. This formula, k plus 1 and k plus 2, right? As in k plus 1 plus 1. So now we just bring 1 over 2. We take 2 to the front. Number 2 is done. So as soon as we know it's true for if we just had k and then k substituted in here. And once we can make it look like this, we're done. And now we can say that what can we say? That this formula works for any n. I was having a moment again. Okay, now let's change. Do you want to take a break?
I don't